Okay, welcome to Chapter 19. We are talking about confidence intervals for proportions. So a couple of things that you need to remember, or that I want you to remember from the last chapter. And that is that we typically have no idea what the true proportion is. Okay, so we want to try to figure out at least what it could be, even if we can't say exactly what it is. This is all going to be leading into all of the word inference. You'll hear that a lot as we move forward. Okay, so we're looking to find an interval, so where P, which is our true proportion, could be based on the results from our sample. So the first example, and if you followed any notes in the book, they talk about this C-fan, and the C-fan is right here. So here's your C-fan. Let's see, because of disease, they're being killed off, and we want to know what the proportion of C-fans that are infected with this disease. So we have a sample of 104 C-fans. Let me get a better color. That does not look good. For some reason, it's on highlighter. There we go. I got it now. Okay, so we take a sample of 104 C-fans and we find that 54 of them have the disease. So these are the numbers that we need to be paying attention to. 54 out of the 104 in our sample. So what can we then say about the true proportion? Well, if we run another sample, obviously we're not going to probably get 51.9%. So how many other samples do we need to try? How many will they vary? So you're going to hear this word a lot too. How much is it going to vary? So we want to know about the sampling proportion, or the sampling distribution of the sample proportions that we would see. Okay, so what do we know? Well, remember in our normal distribution, and that is going to come back a lot in these next few chapters. So in our normal distribution, we have the mean in the middle, so that's what our proportion is. And then we have one standard deviation and two standard deviations on either side, three standard deviations. Okay. We're going to be using this a lot. So I didn't write all the pluses and minuses, but you know that on the right-hand side, we are three standard deviations positive, and over here we are one. Okay, so we also know that one standard deviation on either side is our 68%, two standard deviations is our 95, and three is the 99.7. Okay, so these are numbers that are going to come up a lot. So here we go with the 95% of all the samples will give us a proportion within plus or minus two standard deviations. We get the 95% because we are two standard deviations away. So we have discussed this before, that from here to here is 95% of where we expect our values to be. Well, we can't find the standard deviation since we need to know what that true proportion is. So we're going to calculate standard error. And that came up last chapter when we talked about variability. Okay, so here's where our standard error is. So the standard error of our p hat is the p hat times q hat. Remember, the q hat is 1 minus the p hat all over the n and the square root of that. Okay. All right, so we do know that 95% of random samples, or our p hat, will be no more than two standard deviations or standard errors away from the p. Okay, so if we reach out our hands and say, okay, I want to look at 95%, I want to be 95% sure that p will be within two standard deviations in either direction. That's what we're saying. Okay, you're going to hear that said a lot, and that's really where the focus needs to be. So 95% sure that your true proportion is going to be within two standard deviations, and it's 95% sure because it's two standard deviations. Okay, all right, so but we still have no guarantee. We don't know for sure. We think that it might be. We're 95% sure that it might be, but there's that little tiny piece that it might not be in between our 95%. And that's why we call it a confidence interval. I'm 95% sure that my P will be within two standard deviations away, or looking at that standard error from where the true proportion is. Okay, so 95% is not 100%, but it's really, really good. It's really close, and that's what you're going to hear that a lot. Okay, so with our C-fans, we have the standard error of our p hat And we had, with the one sample we took, we were 51.9% of them had the disease. So our p hat is 0.519, then 1 minus that is our q hat, and we had a sample of 104 CFANs that we looked at. Okay, so our standard error is 0.049. So 0.519, I know there's tons of numbers, but that's kind of where we're headed in this stats class now. So 0.519 is what our p hat is. 2 standard deviations above that get us to 0.617, and 2 standard deviations below that gets us to 0.421. Okay, so this is the importance of what we need to say. This must be written in your notes because this is exactly how you're going to write it. Okay, so we are 95% confident, and then in parentheses, that's the 2 standard deviations. We're 95% confident that between 42.1%, right here, and 61.7% of the CFANs are infected. Okay, so that's all we can say. We can't say anything else. All right, so here's a list of what not to say. So don't say any of these things. 51.9% of the CFANs are infected. Nope, we don't know that because we only looked at one sample. It's probably true. Well, we're not going to use the word probably at all in statistics. We know that the true proportion, well, we don't know that. We're 95% sure. Okay, we don't know anything. And we know the true proportion is probably between. Okay, so the words probably, the words no, we don't want that at all. So this is all we want to say. We are 95% confident that between 42.1% and 61.7% of CFANs are infected. That's all we can say. We don't know anything more than that. Okay, so it's called a confidence interval because we are 95% confident that this is our interval. Okay, so you're also going to hear it called a 1 proportion Z interval, and there are more varieties of this as well. Okay, so here's the 1 proportion Z interval. Okay, all right, so actually I'm going to get back to that in a second. So on this line that you see here is where the true mean is, or the true proportion is here. And these are all the different confidence intervals depending on the grouping of CFANs that we selected. Okay, so if you look at this, okay, look at all these different samples. They produce a different confidence interval. All right, so if we looked at another sample of 50 out of 104, we might get one of these. Okay, but if you look, they're pretty good. Only a couple. This one totally misses what the true proportion is. This one misses it, and this one misses it. But generally speaking, they all catch what that true proportion is. Okay, so that's the idea with the confidence interval, that we are 95% confident that. Okay, and then we have what that interval is. So just a few of them missed, but most of them were right. We're right there. Okay, so that's the idea. You might want to rewind it and make sure that you really caught that, because that's the importance of this section. Okay, so the central limit theorem tells us that if we selected many samples and we collected many confidence intervals, 95% of the intervals will contain P and only 5% will miss them. Okay, so if 100 samples were drawn, 95 of them would create intervals that catch P and 5 would not contain P. Okay, all right, so now we're going to look at margin of error. So the extent of the interval on either side of P hat is what's called the margin of error. So generally it looks like this. We have an estimate, we have our P hat, and we're going to add or subtract what that margin of error is. So the more confident you want to be, the larger your margin of error must be. Okay, so if you want to be 99% confident, you'll see how that changes versus 90% confident. Okay, so how do we become more confident? Well, we widen the interval to catch P. So we increase the margin of error. So to be 99.7% confident, we go above that 3 standard deviations. Because remember, in our 3 standard deviations, we're going to be out here or way out here. Okay, so we have all of this. 99.7% is everything in here. So that's where our 3 standard deviations get us. So usually you're going to see 90, 95, or 99% confidence interval. Okay, and the other thing is you want a bigger sample size. The bigger sample size you get, the the closer to the true p-value will be, because if you have a larger sample size. Okay, so, all right. Critical values. All right, so here's the next part of this. We've talked about confidence intervals, we've talked about margin of error, and now we're going to talk about critical values. Okay, so the number of standard errors or standard deviation that you want to be above or below is what's called the critical value. All right, so you're going to notice that what we have been using has been a little bit of a rounding. All right, so Z with this little asterisk next to it is our critical values. Okay, so we've been using a Z asterisk value of 2 for 95% because we've been saying 2 standard deviations, but in reality it's 1.96. Okay, so if we're looking at our margin of errors and our standard deviation, we want to be more exact. Okay, so there's a table. You're going to want to copy this down in your notes. So the following slide shows a chart of the common values. All right, what is most important is the confidence level, so this column and this column. Okay, the rest is important as well, but this the confidence level and then what that critical value is what's going to be important. Okay, and we have used these before. So if we have a 90% confidence level, the 10% is the left that's not there. So just 100% minus the 90%. Okay, these are the tails, each side of the tail. So it's this value column divided by 2. Okay, but it's the confidence level with what the critical value is that you want to make sure you have in your notes. And I'll be referring to this in the next few examples. Okay, we still have the same conditions and assumptions, and as you work through these problems, you need to make sure you include all of this. Okay, so first of all, the sample size assumption. I think this is now the third time you've heard this in a different chapter. You need to show that there are 10 successes and 10 failures. You need to show the independence assumption. Okay, that you have a plausible independence condition, that the values that you're calculating are independent from one another. Okay, that they were found by randomizing, so probably a simple random sample was collected, and that you need to show that the sample size is smaller than 10% of the population. Okay, so just make a list of those because you're going to have to check this off. You will have to find the sample size assumption, and you will have to go through this independence to show that we can actually use these models. Okay, so here's some formulas for you. So when those conditions are met, we proceed to finding what the interval is. So we have p hat plus or minus the critical value, so this Z with the asterisk, that means that it's the critical value, times the standard error of p hat. And the standard error of p hat is really finding what that standard deviation is, because that's going to really called now is the standard error. Okay. All right, so here's an example. So your local newspaper polls a random sample of 330 voters. So these are important things to write down. You find 144 of them who say they will vote yes on the upcoming school budget. All right, so our first thing to do is create a confidence interval for the actual proportion of those that will vote yes. And then we're going to show it with a 95% confidence interval and a 99% confidence interval. Okay, so what are the things that we need to know from here? Okay, so we're going to calculate p hat. And the p hat is 144 said they're going to vote yes out of our 330 people who were polled, and that ends up being 0.436. Okay, so now we have to figure out our confidence interval. So p hat plus or minus Z with the asterisk. The standard deviation p hat, q hat over n. Just as a reminder, while I'm writing all this out, you could pause the video and write it out and see if we get the same answer. That would be a great way to be showing that you understand this. Okay, so the first one we'll do is the 95%. Okay, so 0.436 plus or minus. Now 95%, so you're going to pull the information off that table, tells us that that critical value is 1.96. And then underneath our square root, p hat is 0.436. And then q hat is 0.564. And 330 people were polled. Okay, so if you're using a TI-84, you could use the second enter button and be able to figure this out, and then just it pulls back the information you just put in and you change the plus to a minus. Okay, so when you figure these values out, I'm not going to go through all of that math, but when you figure that out, you get 38.31% to 48.89%. Okay, so the way we word that is, I am 95% confident that between 38.31% and 48.89% of the voters will vote yes on the, whatever it was, the school board referendum. Okay. All right, so 95% confident that between 38.31% and 48.89% will vote yes. So now if I change that confidence interval, so let's see what happens, okay? So it's still 0.436 plus or minus, and now I've changed to 99% confidence interval, okay? This all in underneath the square root came out to 0.027. Okay, so now when I figure out that, I am 99% confident that 36.6%, that between 36.6% and 50.17, I can read my handwriting, 17% of the voters will vote yes. So because I have a wider, I'm 99% confident. Okay, so now I've switched that it's just these little tails that I'm not going to look at. So this is now wider because it's 99%. I've increased the confidence level. So these numbers get wider as well. Okay. All right, so please make sure you wrote down the wording of that. Okay, so finding a required sample size. All right, so here is another way to write it. So the margin of error, which we just calculated. Okay, we did the margin of error, but I wrote it in terms, this right here is the margin of error. I took p hat and I added and subtracted that. Okay, but the margin of error is this right here. Okay. Okay. So I will tell you the margin of error that we're looking for. So when you're asked to find a sample size, you're given the margin of error, you're given the confidence level, and you are given what p hat and q hat are, all divided by n. Now, sometimes we don't know what p hat and q hat are, so we want to use the greatest value that it could be. So here's a special note. So if we're not given p hat, you use that p hat is 0.5 and then q hat is 0.5 to figure out what the sample size will be. Okay, so if we don't know what that's going to be, sometimes we don't. We just want to say, what is my sample size going to be? Okay, so just if they don't give it to you, that's what you would do. Okay. All right, so here's my example, and let's look at margin of error again. So an example finds that 27% of 53 subjects report improvement after using a new medicine. Okay. All right, so let's check there's really not a lot of information given in here. Plausible independence. Well, okay, I don't know how they picked the 53 subjects. I don't know how many total people there are. 53 is obviously going to be less than 10% of all of the people that probably are using the new medicine. Okay, 10 successes and 10 failures. Well, I have almost 30%, which is 10, and then my failure is going to be 10 as well. Okay, so I feel like they haven't given us enough information in this, and I think that when you see your homework problems, you will be given a lot more information. But just so you understand what it means as going through these, okay? All right, so first thing we're going to do is create a 95% confidence interval. Okay, so my p hat is 0.27. Oops. My p hat is 0.27. Okay, so my 95% confidence interval is going to be 0.27 plus or minus. My 95 again is 1.96, and the square root of 0.27 times 0.73 and that's all over 53. Okay. All right, when you do the math, you come out with between 38.96 and 15.044%. Okay, so again, the wording, I am 95% confident that between 38.96% and 15.044% of people will report that they have seen an improvement given the new medication. All right, so paying attention to those numbers, let's see what happens when we have a 90% confidence interval. Okay, so think first. 90% confidence interval means what just happened to the normal curve. Okay, yep, we made it. It's narrower now. Okay, so we have 0.27 plus or minus, using the number on the chart, 1.64. And I know from doing the previous problem that what was under the square root was 0.061. And that ends up being between 17%. The order of the numbers really doesn't matter if you want to go the smaller to the bigger or the reverse of that. Between 17% and 37%. Okay. So I am 90% confident that between 17 and 37% of the people will show improvement or report improvement with the new medication. So we found a narrower confidence interval, which means that the numbers here actually increased. Okay, so we need to think about that as we move forward and we talk about hypothesis testing, because that's going to be the next chapter. Okay, so we have 90% confidence, and now these numbers went up because we have made the confidence interval narrower. Okay, so it's probably opposite of what you're thinking, but if you draw the picture and you really think about that, it makes perfect sense. Okay, so now we're going to talk about finding the sample size. So with the sample size, we're looking for n. Now we're saying, what is the required, here's the question, what is the required sample size for a 5% margin of error with 99% confidence? And we're going to stay with the same 27% sample proportion. Okay, so this is just a plug and chug formula, just math, where you have to solve for n. So let's put this all together. Okay, so we have the margin of error. I always like writing the formula down first, so I have a game plan. Okay, so the margin of error is equal to the critical value times the square root of p hat q hat over n. Okay, so this is what we want to be solving for. We're going to know everything else. Okay, so the margin of error in this case, it said 0.05. And the z-score, it said 99%. So that critical value, excuse me, is 2.58. And under our square root, we're using the same 27%. So 0.27 times 0.73 divided by n. So again, this n is what we're solving for. You might have a different plan of how you want to solve this, okay? I'm just going to go through it how I would do it, okay? So at first, I'm going to divide 0.05 by 2.58. I always write my steps so that I know if I make a mistake. So 0.0194 is equal to the square root of, and I'm going to use my calculator and simplify, 0.1971 divided by n. Okay. My next step would be to square this. Let's go over here. So I'm not going to use my calculator yet. So 0.0194 squared is equal to 0.1971 over n. Okay, so really this is two proportions. Okay, so we're going to multiply both sides by n and divide by this. So it would be 0.0194 squared times n equals 0.1971. You don't need to write all of this out. And then I'm going to divide by 0.0194 squared. Oops, that's a 2. Okay, This cancels. So n is equal to 0.1971 over 0.0194 squared. Okay, can never have a decimal when we're talking about sample size because we can't have a part of a person. Okay, so when we get that out, I don't know what the decimal was, but I rounded it to be the next whole, 524 would have to be my sample size to have a 0.05 margin of error and have a 99% confidence interval. Okay, so I would need to poll or interview, however I want to do this, 524 people, or not interview that many people. I'd have to have that many respondents in order to be able to have that margin of error. Okay, all right, so you have some example problems in your homework to do these as well. All right, so a couple more things about sample size. So the standard error declines with the square root of the sample size, because if we look at the formula, that's what's happening. All right, in order to, if we want to decrease the standard error, okay, then we have to look at the square root of the sample size. So to cut the standard error in half, we have to quadruple the sample size in order to do that, because we're talking about a square root. Okay, so just some other things. Please make sure as you do your homework that you have these examples written in your notes so that you have something to look back on. All right? Okay, that's it with Chapter 19.